Hello everyone and welcome back to the channel. In this video we are going to continue the topic of monomials. This one is going to be a shorter video. What we didn't talk about in the last lesson was addition and subtraction of monomials. So let's do this right now. The first thing we want to know is what are similar monomials. Okay, so similar monomials are monomials which differ only in their coefficients. Okay, so for example, if I have 2x to the power of 2y to the power of 3 and 5x to the power of 2y to the power of 3, those are called similar. The variables are the same with the same degree. The only difference is the constant or the coefficient. That's the only difference, okay? If I have, for example, 2x to the power of 2y to the power of 2 and 5x to the power of 2y to the power of 3, not similar, okay, because they differ in the power of one of the variables. So if there's any other difference apart from the coefficient, they're not similar. In the same way, if I have, for example, 2x to the power of 2y to the power of 3z, let's say, and 5x to the power of 2y to the power of 3, without the z, they're not similar, because I have an additional variable in the first monomial. Okay, so far so good. One last example. If I have, for example, 2a x to the power of 2 and let's say minus 5x to the power of 2, they are similar because I'm usually counting a as a parameter, okay, and therefore the variable is just x squared. They have the same variable to the same degree and only the coefficient is different. Now what I want to say here is that the rule is we add only similar monomials, okay? If the monomials are similar, we can add them. If they're not similar, we cannot add them together. We add them by adding their respective coefficients and copying the variables. Okay, so for example, it's very simple. If I have 5x squared y plus 7x squared y, this will become 12x squared y, okay? I just add the 7 and the 5 together, which is again a property, you know, the distributive property of numbers. The common factors can be taken outside of brackets, right? And in the brackets I have just 5 plus 7, which is 12. In the same way, if I have, for example, 10x to the power of 3y minus let's say 15x to the power of 3y, this is minus 5x to the power of 3y. And now the more tricky examples are when I have a parameter. So for example, if I have, let's say, 2a x to the power of 3 plus 5x to the power of 3, I perform the same kind of operation. I take the x to the power of 3 as a common factor and I add the coefficient, so I add 2a plus 5. But because I don't know what number a exactly is, I just leave it like that in brackets, okay? So this will become 2a plus 5 in brackets times x to the power of 3. Again, this is a monomial because 2a plus 5 is a constant. It's part of the coefficient. It will be a different story. I've written some exercises here, so I'll just write it in the corner here. It will be a different story if I have, for example, 2xy plus 5x. Now, because these are not similar, I cannot add them, okay, and get a result as a monomial, okay? They're just left like that, so we don't add them because they're not similar. But if I have 2ax to the power of 3 plus 5x to the power of 3, these two can be added because they're similar. All right, now we'll see the exercises. Add the monomials u, v, and w. All right, so u plus v plus w will be minus 3x to the power of 3y to the power of 2 plus 2. Now this one is not in standard form. To make it in standard form, I just multiply x times x squared. It will become x to the power of 3, so 2x to the power of 3 y to the power of 2 minus 4x to the power of 3 y to the power of 2. Okay, and now I see that they're similar in all of them. The variables x to the power of 3 y to the power of 2 are identical. So what I do, I just add their coefficients here. Minus 3 minus 4 is minus 7, plus 2 is minus 5. So I get minus 5 x to the power of 3 y to the power of 2, and that's the answer. Okay, good. Simplify the expression. So the first one, in long expressions like this, it is useful to look for what are called opposite monomials. They are monomials with similar monomials with opposite coefficients, and when I add them I get 0. For example, 3ax minus 3ax, they're similar, I add them, but I get 3a minus 3a, which is 0, so they just cancel, okay? And I keep up adding the others, so they're all similar. Add the coefficients. 2a plus 10a will be 12a, plus 6 will be 18a, minus 1 will be what, 17ax, right? And this is my answer, 17ax. 2 plus 10 is 12, plus 6 18, minus 1 17. What about the next one? Do I have any opposite monomials? Yes, 10 and minus 10 will cancel here. So I get minus 9a minus a will be minus 10 plus 5a. So I get minus 5a x to the power of 3. Okay. What about this one here? Do I have any opposite monomials? Yes, I have 2/5 and minus 2/5. This will cancel. Now I add this here, 1/2 minus 3/4 plus 1/4. So 1/2 is 2/4 plus 1/4 is 3/4 minus 3/4, and actually they will also cancel, right? And I'll get just 0 as a result. What about here? I have minus ay plus ay, they cancel, and then I just need to add 1/2 plus 2/3 plus 1/6 ay. This will be 6 here, 3 2 1. So 3 plus 2 3 plus not 2, this is yeah, okay, so 3 plus 4, 2 times 2 is 4, 3 plus 4 is 7, plus 1, 8 over 6 ay, 4 over 3 ay, okay, and this is my answer here. Okay, calculate the value of the expression. It's the same, so I add 2 plus 9 is 11, minus 12, this is minus 1x or minus x. This is going to be minus 2.8, which is 2.8. Here I have x squared y minus x squared y, those cancel. 6 plus 3, 9, minus 4, this is going to be equal to 5 x squared y. I substitute the numbers, so I have 5 minus 2 to the power of 2 is 4, so 5 times 4 times 3, which is 60, right? And that's my answer for this exercise here. What about this one? I need to present in standard form, right? They're not in standard form. So the first one, I need to multiply 2 times 3 is 6, x to the power of 3, y to the power of 2, then minus 10, x to the power of 3, y to the power of 2, plus 8, x to the power of 3, y to the power of 2. So I have 6 plus 8, 14, minus 10 is 4, x to the power of 3, y to the power of 2. Substitute the number, so I get 4 times minus 3 to the power of 3 is minus 27, minus 1 half to the power of 2 is 1/4, cancel, minus 27, and that's the result here. Now when I multiply monomials, it's exactly the same as the procedure to turn them into standard form. I multiply constant by constant, variable by variable, okay? So in this exercise here, I have these three monomials. I need to multiply them, so minus 2xy squared times 0.2 x to the power of 2 times 4y to the power of 4. So I multiply the constants, I get minus 2 times 4, this is minus 8, times 0.2 will be what, minus 1.6. Multiply the variables, x times x squared, this is x to the power of 3, y to the power of 2 times y to the power of 4 is going to be y to the power of 6, and that's the answer, okay? Open the brackets. We know how to do this by applying the properties for power numbers. Every factor in the brackets is going to be raised to the power of 4 in the first case. So minus 2 to the power of 4 is 16. X to the power of 7 to the power of 4 is x to the power of 28. Y to the power of 3 to the power of 4 will be y to the power of 12. In the second case, minus 3 to the power of 3 minus 27, x to the power of 3, y to the power of 6. Perform the division, u divide by w, so minus 8ax to the power of 3, z to the power of 7, divide by minus 4, x to the power of 2, z to the power of 7, z to the power of 7, z to the power of 7 cancel. Minus 8 divided by minus 4 is 2. X to the power of 2 with x to the power of 3 will cancel. Here in the numerator I'm left with x to the power of 1. So the result will be what? 2ax. 2ax is what is left, okay? Calculate the value of this expression. So again, multiply first. A equals to minus 10 x to the power of 4 plus 25 x to the power of 4, plus x to the power of 4. So minus 10 plus 25 is 15, plus 1 is 16x to the power of 4. So minus 1 to the power of 4 is 1, so I get 16 as a result, right? I can make a mistake. If I make a mistake, please correct me in the comments below. But I think so far so good. What about b here? Actually, probably I need to write it on a separate page, or maybe I'll just zoom out a little bit here to have space. So b is going to be equal to 9x to the power of 2 times 2x plus 6 divided by 2 is 3, x to the power of 3 minus 12 x to the power of 3. Okay, so this is 18x to the power of 3 minus 3 minus 12 is minus 9 x to the power of 3. So finally I get 9x to the power of 3. And if x is equal to minus 2/3, this is going to be 9 times minus 2/3 to the power of 3. This is minus 8 over 27. Cancel the 9 with the 27, I'm left with 3. Minus 8 over 3. Okay, and this should be my answer here. And now for c, for the expression c. Okay, just move below. c is equal to 3x to the power of 3 y to the power of 4 minus 5x to the power of 3 y to the power of 4 minus 4. Again, 5 minus 2 is 3, x to the power of 3, 6 minus 2 is 4, y to the power of 4. So I have 3 minus 5 minus 4. This is minus 6, right? Minus 6, x to the power of 3, y to the power of 4. Now x is 2 and y is minus 1/2. So minus 6 times 2 to the power of 3 is 8. Minus goes away when we are raising to the power of 4. So it's going to be 2 to the power of 4 is 16, so 1 over 16. So this is minus 48 over 16, which is minus 3, and this should be my answer here. Okay, well, this is how basically we operate with monomials. We can multiply them, we can raise them to some power, we can add them, subtract them, etc. Okay, that's it for today. In the next video we're going to continue with polynomials. All right, if you have any questions, let me know down in the comments below. Like and subscribe, and I'll see you in the next one. Bye for now.